we have to place artificial satellites into the space. When we are placing these artificial satellites into space, we need some launch vehicle. Okay, so those vehicle, so satellite launch vehicle. So what is it? Means usually it is the vehicle through which we will place them. So the name itself, it talks about the vehicle to launch or place the satellites into space. Can you able to understand? So when we talk from the perspective of India perspective, so we have different types of launch vehicles. Okay, so there we have first generation vehicles. Okay, and we also have second generation vehicles, and we have third generation vehicles, and we also have fourth generation vehicles. That means as far as now concerned, we have 4 generations of vehicles, launch vehicles. Okay, so if you look from India's perspective, we have something called satellite launch vehicle. So SLV, satellite launch vehicle, was the first generation launch vehicle that we have developed in India. Okay, then at the next level we had ASLV. ASLV. So this is satellite launch vehicle, and this would be augmented satellite launch vehicle. Augmentation means something enhancing. So a slight enhanced version of the satellite launch vehicle is known as ASLV, that is augmented satellite launch vehicle. Okay, so that is one thing. And next thing, third generation, we have something called PSLV. So here PSLV refers to Polar Satellite Launch Vehicle. Look at the names. Names are very, very important. Okay, Polar Satellite Launch Vehicle. That means these launch vehicles are generally used to place, generally, I am using the word generally, they are used to place satellites into polar orbits. Into polar orbits. Okay, now you have to recollect what is the distance of polar orbit, what kind of satellites would be placed in polar orbit. All these things you have to remember. If you can understand this logic, then whenever you get a word like, for example, PSLV launch vehicle has been used, then you can decode all those things without having anything. If they are using PSLV, that means they are intended to keep the satellite in polar orbit. So then if you understand the distance and if you understand the purpose, so all those things would be eventually decoded. You can decode it. Okay, that means this would be used to place satellites. Polar orbit means low Earth orbit. Okay, low Earth orbit. So this is one thing. So usually what we will place in low Earth orbit, if what kind of satellites would be placed in low Earth orbit generally? Yes, so remote sensing satellites. This is not our RSS, remote sensing satellite. So remember this, means generally you remember this. Okay, and now this is Polar Satellite Launch Vehicle. Okay, then fourth generation launch vehicle is known as GSLV, geostationary or geosynchronous satellite launch vehicle. Okay, the name itself says geostationary or geosynchronous satellite launch vehicle. So that means when we are saying it as geostationary orbit, so remember, like let's take for our stationary orbit. So now can you remember the distance where it would be placed? So what kind of orbit it is? Is it low Earth orbit or high Earth orbit? So good. So it is high Earth orbit. Okay. So this orbit is also known as generally to say GEO, geostationary Earth orbit. Okay. So this is high Earth orbit. So what kind of satellites will place here? Good. So communication satellites and also some Earth observation satellites. Some. So exception would be there. Some communication satellites can be placed here. Some remote sensing satellites can be placed here. Some. But majorly that would be the criteria. So remember that. So it is fourth generation launch vehicle. Now if we try to understand the differences between them, what are the differences between ASLV, PSLV, ESLV, all those things means, if you look from the perspective of these two, so they are the older versions. They are the older versions where we had solid fuel. We used to rely on solid fuel. Okay. So with respect to ASLV and with respect to PSLV, SLV particularly we had relied on solid fuel. So what kind of solid fuel would be generally used means here we will have something called HTPB. HTPB. So you can remember like HTPB. So somewhere you can write solid fuel HTPB. HTPB means hydroxyl terminated hydroxyl terminated poly hydroxyl terminated polybutadiene. Polybutadiene. So this is the solid fuel that would be generally used in the launch vehicles. Based on the tech at India. So Indian, we are discussing about the India's things. Okay, Indian perspective. Okay, so from Indian perspective, these are the developments. Okay, SLV, ASLV, PSLV, and GSLV. Okay, so solid fuel. So this SLV was based upon solid fuel. Okay, so have you heard about Vikas engine? Vikas engine developed by who developed a Vikas engine? Huh? Anyone who developed Vikas engine? Who was the person behind the development of Vikas engine? Dr. APJ Abdul Kalam. Okay, APJ Abdul Kalam. APJ Abdul Kalam was instrumental in developing the Vikas engine. So that was there in with respect to second generation vehicle. Okay, that was ASLV. So there we have introduced liquid engine. Okay, liquid engine we have developed. So liquid engine, that is generally liquid fuel, that is generally fuel would be made up of UDHM. We will call it as, like I'm writing here, so that liquid fuel, what would be the liquid fuel? Try to just get acquainted with these names, so there can be like in exam also they may use that things. Okay, so UDHM. So this is the liquid fuel that would be used here. So you can just mention the full form of it. UDHM means unsymmetrical dimethyl hydrazine. So this is the liquid fuel that is used. Okay, unsymmetrical dimethyl hydrazine. Okay, so that is liquid fuel that is used in launch vehicles. Okay, solid fuels is HTPB, liquid fuel is UDHM. So that is one thing. So this is with respect to this SLV and ASLV. And if you talk from the perspective of PSLV, so what are the important aspects of PSLV? So when we see PSLV is the third generation launch vehicle. So it is understood. So what are the important features of third generation fuel? So try to just have a look here. So it is the third generation launch vehicle. Okay. So here is the first Indian satellites equipped with liquid stages. So there, when we talk from the perspective of this development, so at PSLV level, we have introduced the liquid stage for the first time. So generally, when we talk from the perspective of fuel, so it is, let's say, it is a 4-stage fuel. So you can see here, PSLV, 4-stage fuels would be there. So one would be solid, liquid, solid, liquid. In this arrangement, 2 solid stages and 2 liquid stages would be there. That means when a launch vehicle, just see, a launch vehicle will be like this. So here fuel would be filled. So first stage they will have solid, then liquid, then solid, then liquid. Okay, likewise, they will fill the chamber, fuel chamber, with this kind of fuel, so that solid fuel will have lot of efficiency, so it can give good thirst. Okay, then liquid fuel will have it will have different advantages. So then again solid, again thirst, again liquid. So likewise, so PSLV will have 4 stages of fuel. So what is the order? Solid, liquid, solid, liquid. This is the order. Okay. So in the similar fashion, if you see GSLV, it is the 4th generation launch vehicle. So it will have 3-stage fuel. Stage number of stages would be 3. So what are those stages? Means solid, liquid, and cryogenic fuel. Okay. So solid fuel would be made up of PTHP, and liquid fuel would be made up of UDHM, and cryogenic fuel. Cryogenic fuel means the fuel which works at extremely low temperatures. Extremely low temperatures. So usually cryogenic engines are cryogenic fuel. So when we talk from the perspective of this cryogenic fuel, usually whenever you get the word cryogenic, it is at extremely low temperatures. Okay, so cryogenic fuels will have generally 2 components. One would be oxidizer and other would be fuel. That means cryogenic engine will have 2 components. One would be oxidizer and one would be fuel. So here when we talk from the perspective of this, so it will have liquid oxygen. Liquid oxygen. So that liquid oxygen serves as oxidizer, and we will have liquid hydrogen. Liquid hydrogen. So this serves as the fuel. This serves as the fuel. So liquid hydrogen and liquid oxygen. So these are the components that would be present in cryogenic engines. Okay. So here when we talk from the perspective of them, so we are saying that they are at very low temperatures. To say liquid oxygen, usually oxygen gets liquefies at a temperature of minus 183 degrees centigrade. Minus 183 degrees centigrade we are talking. Okay, 100 degrees is the boiling point of the water. So if we take them to minus 183 degrees centigrade, at this temperature it gets liquefied. Okay, so that means that much would be the low temperature. Okay, and in the similar fashion, if we talk from liquid hydrogen's perspective, hydrogen when it is subjected to around minus 153 degrees centigrade, so then it gets liquefied. Hydrogen gas, it gets liquefied. So at this temperature we will use them. So at this temperature they will behave like cryogenic material. So that's how cryogenic fuel and cryogenic engines will use these 2 things. So in simple fashion, how we will write them means this liquid hydrogen would be written like logs. Okay, so that the other way, like we will write this liquid hydrogen as LH2. So this is how we will represent in technical sense. Okay, try to remember that. So this is with respect to the cryogenic fuel. So now try to come back to this. Now you see solid, liquid, and cryogenic engine, cryogenic stage. At cryogenic stage, oxidizer would be there as well as liquid hydrogen fuel would be there. So that is the fuel. Okay. So now I hope you have understood what is the solid fuel, what is the liquid fuel, what is the cryogenic fuel. Okay. In the similar fashion, if you see from the perspective of GSLV, so advanced versions of GSLV are nothing but GSLV Mark III. GSLV Mark III is the advanced version of the GSLV vehicle that we have. And very recently, we also have renamed this GSLV 3 as LVM, Launch Vehicle Mark III. So somewhere you mentioned LVM 3, LVM Roman 3, LVM 3, Launch Vehicle Mark III. Okay, so we'll discuss that with respect in current affairs. Okay, there Where can you remember where we have used LMV3, LVM3 for launch of which project, which mission? Good. So exactly. So Chandrayaan 3. So we have used LVM3 launch vehicle Mark 3 vehicle for launching Chandrayaan 3. Okay. Now you remember. So it is a variant of GSLV Mark 3. It is renamed as LMV3. So that means GSLV. That means you remember Chandrayaan 3. So distance. Now you can catch all those things. Okay. So that is one thing. So to summarize this, so one of the important term that we can accord to PSLV is that it is also PSLV, this launch vehicle is also known as workhorse of the ISRO. Workhorse of the ISRO. So why we are calling it as workhorse of the ISRO means usually this is used for, this is used mostly for launching many satellites. Okay, as far as now, lot of satellites have been launched from India by using PSLV vehicles. Are you getting? So that's why we will call it as workhorse of the ISRO. Okay, so that is one thing. So usually we will use this PSLV to launch satellites into low Earth orbits. This you have to remember. Okay, so particularly remote sensing satellites. So then if you see the things, examples for such kind of satellites means like remote sensing satellites like Cartosat. Cartography. Cartography is the art of mapping. Art of mapping is nothing but the science that deals with mapping of various things is nothing but cartography. Okay. So then OceanSat. That means this satellite is intended to look at various aspects related to ocean mineralogy, ocean, all those things, OceanSat. So RISAT. So these are some of the remote sensing satellites. Okay, examples. So we also used Chandrayaan 1. We have launched Chandrayaan 1 with the help of PSLV. Okay, so Mars orbiter mission, Mangalyaan. So we have also launched Mangalyaan by using PSLV launch vehicle. That means to say, to be precise, Chandrayaan 1 has been launched by using PSLV-C2 launch vehicle. And Mars orbiter mission, PSLV C25. So we have used these launch vehicles to launch them. Okay, so that is one. So along with this, we also have something called Indian Regional Navigation Satellite System. So IRNSS. So this IRNSS is also has been launched by using PSLV. First, we have placed it in geosynchronous transfer orbit. So what is geosynchronous transfer orbit? GTO here. GTO. We have said GEO was there one thing, and polar orbit was there one thing. And what is GTO? Geosynchronous geostationary transfer orbit. Now you see, what is the transfer orbit? What is the transfer orbit? Middle Earth orbit. Can you able to understand that? GTO means geostationary transfer orbit or geosynchronous transfer orbit. That means first to take them to these heights, we will place them at this height. From this height, it would be taken. So can you able to recollect the highly elliptical orbit we saw? So this is also known as geostationary transfer orbit. So GTO, it is known as polar orbit, it is known as GTO, it is known as GEO. So geostationary orbit, like this. So GTO means middle earth orbit. You can remember like this. So here, when you see, if you talk from the perspective of this, so we have also used PSLV launch IRNSS by PSLV to place it in GTO, geotransfer orbit. So that was one. So then, if you talk from the perspective of GSLV, so it is the 4th generation thing, and it is the most advanced thing. So it is 3-stage launch vehicle. We have understood that. So solid, liquid, cryogenic engines, it would be there. And what is the common purpose? We will use GSLV to place communication satellites into GTO or GEO. So that is one. So GSLV's purpose is placing communication satellites. Remember that. Okay. Then, if we talk from the perspective of examples, we have 2 types of satellites, communication satellite, INSAT series and GSAT series. Okay. Indian National Satellite Series and GEO satellite series. So INSAT and GSAT, these are the communication satellites. Like let's say for example, INSAT 1, INSAT 2, INSAT 1A, that is one series of communication satellites. GSAT 1, GSAT 2, GSAT 9, GSAT 11, that would be other series of communication satellites. So जहाँ पर भी आपको ये मिलता है तो आपको ये समझना कि it is a communication satellite like RISORSAT, RISAT, CARTOSAT. So they would be Earth observation satellite or remote sensing satellites. So they'll be placed in low Earth orbits. So these things would be placed in high Earth orbits. Can you able to remember now? So now, GSLV, when we talk from the perspective of GSLV Mark III, GSLV Mark III is the most advanced version that we had, and we developed it in 2000, tested in 2017-14, and we have used it for the first time in 2018 onwards, 17 and 18 onwards. Okay, we have started using it. So we have renamed, you remember, we have used Chandrayaan 2 mission, launched Chandrayaan 2 mission by using GSLV Mark III. And in India, we also have some sentiments. So we could not able to reach our aim and target with respect to Chandrayaan 2. So we could not able to go for soft landing. So this might be another reason that why they have named this as LVM3, Launch Vehicle Mark III. Okay, so that is other thing. So Chandrayaan 3 has been launched by using LVM3. It is synonymous to GSLV Mark III. Are you getting that? So if we are saying this GSLV Mark III, immediately you have to remember all these things. Okay, there should not be confusion. Again, I am saying why we focused on basics means we should never confuse with these things. Okay, so that is one thing. So payload, this is for a technical purpose, but you can remember the weight. Just check the weights and you will get that thing. Yes. Is if you see, each fuel will have advantage. For example, if you are using solid propulsion, that means if the propulsion system is made up of solid fuel, so for example, there would be some advantages, there would be some disadvantages. If you see, for example, if you are using solid fuel or solid propulsion system, then you see solid can be easily stored. Solid materials can be easily stored. So that is an advantage. And if you see, we can reach high speeds very quickly. Like for example, if you take any bomb and it gives explosion and the amount of energy released would be very high immediately. That means solid fuel will have quick thirst. It gives very quick thirst. That means it can for having high thirst, it will be used. Solid would be used at the first steps. So it has to go heights. So thirst should be high. So that's why always solid fuel would be at the first stage. You can take any vehicle, either it can be SLV, it can be ASLV, or it can be PSLV or GSLV. First stage would be made up of solid fuel because it gives good thirst so that they can reach high speeds very quickly. Once they have reached high speeds, obviously you assume when they reach high, gravitational pull will be reduced. When gravitational pull is reduced, obviously it requires less fuel. Are you getting that? So when it wants to move away, it should overcome that gravitational pull. So near the Earth's surface, gravitational pull will be more. So to overcome that, it has to have good thirst. So for that, we will use solid propulsion system at the first stage. Are you able to understand that? So then, if you look at the liquid propulsion system, so advantage is that, like, thing is that it can be controlled easily. Advantage, it can be controlled easily, but problem is that storage will be difficult and storage will be problematic. Okay, but problem is that if we are using solid, it gives a lot of weight, so we also have to reduce weight also. If you have more weight, then more fuel would be consumed. So we have used liquid fuel, though storage is difficult, but it can be controlled easily and it gives less weight to the launch vehicle. Are you getting that? So for that purpose, liquid fuel would be used. So generally hydrocarbons would be used, like UDHN. We have written UDHN. That is one common liquid fuel. Okay, so then we'll discuss about ramjet and scramjet with respect to defense technology. Okay, so there cryogenic fuel. So cryogenic fuel means here you see solid, liquid and gas. Now why we are moving towards solid gaseous fuel means, think about the weight. Think about the weight. So weight we have to reduce. When we reduce the weight, obviously the weight of the launch vehicle, fuel consumption will be reduced. So that's why the liquid, this cryogenic stage, it includes liquefied gases. Liquefied gases. So thus they will give added efficiency to that. So that is one way. At the third stage, we will use this thing. Okay. So remember, with respect to this processing of this technology, like cryogenic engines, India is the 6th country to have cryogenic technology, cryogenic engine technology, along with these countries like USA, Russia, France, Japan, China. These are the other countries that we have the cryogenic engine technology. Okay, remember, that is another important. So these are basically with respect to launch vehicles. Okay, so with respect to launch vehicle also, you should remember all other data. For example, if you are using PSLV, things should serve in your mind that generally it is used for polar launch vehicle, polar orbits. Polar orbit means low earth orbit, distance. So which kind of satellites would be placed, these things should come into your picture. Okay, so likewise, map likewise. So that's why we have gone in a technical way. Okay.